Okay, ladies and gentlemen, let's finish what we were working on last time when the power went out. What we were doing was something to the effect of, if I had the point negative 6, comma 30, we would still go up the 30 degrees, so our 30 degrees somewhere in here. And we go out 1, 2, 3, 4, 5, 6. But instead of going out 6 in the positive direction, the negative means we go up to 30, but back 1, 2, 3, 4, 5, 6. So our point here is negative 6, comma 30. You'll notice that's exactly the same thing as if we had said around to 180 plus 30, 210, and positive 6. So positive 6, positive 210 is the same thing as 30 degrees, but a negative 6. So in the same way, you could even go the other direction. Now, in vectors, we always went this way. Let's go this other way. You could have 6, comma, negative 150. So whether we're turning the radius negative and going, instead of out, we actually back it up, or whether we do negative angles and go this way, or whether we do positive radius and go this way, it happens over and over and over. Again, if you really wanted to, you could simply take the 210 and you go around all the way and then around again to it. So you could even have 6, comma, 570. All of those are the same point. Let's go ahead and graph another one of those points. Let's go this time with 95 degrees and negative 5. So negative 5, comma 95. Well, 95 would put us right out in here somewhere. And so negative, if it were 5, it would be 1, 2, 3, 4, 5. But instead it's negative 5, so 1, 2, 3, 4, 5. There it is, negative 5, comma 95. Now, that could also be positive 5, comma, add 180 that. If we take 95 plus 180, I believe it should be 275. 95 plus 180. Yeah, 275. You could have also gone the other way. If this is 5 short of that, it's going to be 5, comma negative 85. So any of those options are ways to plot that point right there. Now, what we're moving to next is, once I have 2 points, these, in essence, could be vectors. But what I'm looking for is I'm looking for the distance between 2 points. Now, what you end up with is, if I were to connect that line and this line, and I want to find the distance between 2 points, I've just made a triangle. And that triangle is not a right triangle. I do know this side is 6 units long. I do know this side is 5 units long. And I can figure out that the angle between them is, let's see here, we had 210, we had 275. So it's going to be 65 degrees. With that, I could use the law of cosines, because I know a side, an angle in the middle, and a side. If I were to do that, I would use the following formula. This formula right here is really just the law of cosines, where you have one side, the other side, minus 2 times the first side, second side cosine. Now, the only change is right here, where you have theta 2 minus theta 1. Well, theta 2, in our case, the bigger one, 275, minus theta 1, 210, the angle was 65. So they put the subtraction of the thetas just into the formula. Now, if we were to do one from scratch, let's go with 3, 42 and 8, 150. So 42 is going to be somewhere in this ballpark, and go out 1, 2, 3. And if I have 8 comma 150, 150 is going to be in this ballpark. And I go out 1, 2, 3, 4, 5, 6, 7, 8. So there we go. We have 3 comma 42, 8 comma 150. We can graph them. Now I want to find the distance between them. To find the distance between them, I can create a triangle. I got a 3, I got an 8. And with that, I can begin putting all of that right into our formula. I can say 3 squared, 8 squared, negative 2 times 3 times 8 cosine 150 minus 42. It simplifies here, and if I were to simplify it a little bit further, we would come up with this put into the calculator. Answer is 9.37. Now, if I were to take kind of a look here, if this is 3 and this is 8, 9.37 for the magnitude or the distance between the two makes a whole lot of sense. So, finding the distance between 2 points, you can do it. First problem for your homework. You need to graph. And I will try to put a sheet, this sheet or a sheet like it, on the website for you to download. Graph 6 comma 42, negative 7 comma 30, 16, we better not go 16, let's go 6 comma negative 72. Let's go with negative 8 comma negative 31 degrees. So A, B, C, D. Now, that's problem number 1. Graph those points. Number 2, I want you to find the distance between, let's go A and C. So distance from A to C. So from A to C. Now, additionally, we want to do 2 more little quick things. We could also, instead of just graphing points, we can graph actual whole graphs. Just like we graph a line or a parabola or a cubic function on a set of axes, you can graph the following. R equals 6. That's one equation to graph. And B, the other case, is theta equals 55 degrees. All of those 2 graphs can be graphed. Now, if we wanted to go another way, we could say theta equals pi over 4. That would also be something that you can graph for homework. Those are your homework problems. Make sure you pause, write them down. Let me show you very quickly how to graph these special graphs. Those special graphs are nothing but R equals number is a circle. And it makes sense. If I have R equals 7, I'm going to go out 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And on around just like that until I have every point that is 7 units away from the center. Every point 7 units away from the center. By the way, R equals negative 6 would be, well, instead of going out 6, you go back 1, 2, 3, 4, 5, 6. But by the time you rotate it, it will also be a circle. For theta, theta equals 120 degrees. Well, what I'm looking for is, since I know what theta is, every point is going to have a degree of 120. Don't know what the radius is, but every degree is 120. So, as we graphed our points, you'll notice I drew this dotted line. That is the line, theta equals 120, because it's that radius, that radius, that radius. Every radius represented, both positive and negative, ends up on this line. So theta equals 120 is a straight line. So, your two equations to graph are r equals number, theta equals number, and it's those problems right there. So, make sure you write those down, get them graphed.